This diagram shows an array of 5 numbers. Our objective is to find a pair of numbers that add up perfectly to our target of 6, and to do it without checking every single pair. The standard brute force approach is to take the very first number and start comparing it to every subsequent number in the sequence. Then you move to the second number and repeat the entire process. This logic holds up fine for 5 items, but if you run this operation on a massive dataset, the amount of necessary comparisons squares the size of your input. The calculation bogs down under its own weight. Relying on exhaustive pairing is mathematically unsustainable. Scaling up requires a system that navigates the data logically rather than forcefully checking every combination. Because the sequence is already sorted from smallest to largest, we deploy 2 pointers on the far left and far right. Moving the right pointer backward decreases our total sum, and moving the left pointer forward increases it. Let's test that rule. 1 plus 6 equals 7. That's strictly greater than our target of 6. To reduce our total, we shift the right pointer 1 step left, calculate the new sum, and predict the next move. 1 plus 4 is 5. Since 5 falls short of our target, we must increase the total sum, so we move the left pointer forward. 2 plus 4 is exactly 6. Target matched. We found the answer instantly. By leveraging the physical layout of a sorted array, we turned a random brute force search into a targeted directional navigation. This split screen shows exactly how that physical logic maps to code. We initialize a left variable at 0 and a right variable at n-1. These track index coordinates, not integer values. We run a continuous loop as long as the left index is strictly less than the right index. If they were equal, pointers would land on the exact same coordinate, adding a number to itself. Inside the loop, the logic is a direct translation of our physical rule. If the sum is smaller than the target, increment the left coordinate. Otherwise, decrement the right coordinate. Binding physical movement to conditional loop logic guarantees that the computer only executes what is mathematically necessary, entirely eliminating wasted processing. This side-by-side comparison shows the scale of the optimization. We replaced an exponential web of redundant checks with a clean, single-pass sweep. The time complexity drops from O of n squared down to linear O of n time. When you sit down for a coding interview, you need a mental checklist. The absolute first question you should ask yourself when looking at the provided data is the array sorted? If it is, anchor your pointers at the outer bounds of 0 and n-1. From there, move inward. Sum too small, increase the left. Sum too big, decrease the right. Make this a reflex. A sorted array in any problem description should immediately signal that the 2 pointers method is likely the optimal solution. Internalizing structural rules like this turns high-pressure interviews from daunting memory tests into clear exercises of strategic logic. Follow for more systematic breakdowns of data structures and algorithms.